Welcome to the Oracle's Rest, a place where stories unfold slowly, where time softens, and where the mind is free to wander. Tonight, we explore one of the oldest and strangest questions human beings have ever asked. What is reality? At first, the question sounds simple. The world appears solid. The ground feels stable beneath your feet. Objects seem permanent. Time appears to move forward, and everyday life feels immediate and obvious. But throughout history, many philosophers, scientists, mystics, and religious traditions have all arrived at a similar realization. The reality human beings experience may not be as straightforward as it first appears, because everything you experience, every color, every sound, every sensation, every memory, every emotion, and every thought is ultimately being constructed inside the mind. Right now, your brain is receiving electrical signals from the eyes, the ears, the skin, and the nervous system. And from those signals, it builds an internal model of reality. But human beings never experience the world directly. We experience interpretations of the world created by the brain itself. For example, light does not actually contain color. What humans call color is the brain's interpretation of different wavelengths of electromagnetic radiation. The color red, the color blue, the color green. These exist as experiences within conscious perception, not as physical substances floating independently through space. Sound works similarly. The world itself is silent. What we call sound begins as vibration traveling through air or matter. Only when those vibrations are interpreted by the nervous system does the experience of sound emerge. This means that much of what humans experience as reality is deeply tied to perception itself. And perception can be surprisingly unreliable. The brain constantly filters information. If it did not, human beings would become overwhelmed almost immediately. At every moment, the nervous system receives enormous amounts of sensory data, far more than conscious awareness can fully process. So, the brain prioritizes certain information while ignoring other details entirely. In fact, human beings routinely fail to notice major changes in their environment when attention is directed elsewhere. Psychologists sometimes demonstrate this through experiments involving selective attention. In one famous example, Participants watching a video and counting basketball passes often completely failed to notice a person in a gorilla suit walking directly through the scene. Not because the eyes failed, but because attention itself was occupied. This reveals something important. Reality is not simply seen, it is filtered, organized, and interpreted continuously. Memory works in a similarly imperfect way. Many people imagine memory as a recording device, a stored archive replaying events exactly as they occurred. But neuroscience suggests memory is far more reconstructive than that. Each time a memory is recalled, the brain partially rebuilds it. Details can shift over time. Emotions influence recollection, and entirely false memories can sometimes form under certain conditions. This means that even the past, which often feels fixed and stable, exists partly through reconstruction within the mind. Time itself also behaves strangely when examined closely. Human beings experience time psychologically, not just mechanically. A single hour can feel extremely long during fear or boredom, and incredibly brief during moments of focus or joy. Childhood summers often feel endless in memory, while years in adulthood can seem to disappear rapidly. The experience of time changes depending on attention, emotion, novelty, and memory density. Even physics complicates ordinary ideas about reality and time. According to Einstein's theory of relativity, time is not completely fixed or universal. It can move differently depending on speed and gravity. Clocks positioned farther from Earth's gravitational field actually measure time slightly differently than clocks on the planet's surface. Modern GPS satellites must account for these relativistic differences constantly. Without those corrections, navigation systems would drift significantly over time. This means that time itself is not quite the stable background humans once imagined it to be. The deeper science looks into reality, the stranger reality often becomes. At the quantum level, particles behave in ways that seem deeply unintuitive compared to ordinary human experience. Matter can behave both like particles and waves, depending on how it is measured. Certain properties appear probabilistic rather than fixed, and quantum systems can exist in multiple possible states before observation forces a measurable outcome. Physicists continue debating what exactly this means, and different interpretations attempt to explain the underlying nature of reality itself. Some interpretations suggest probabilities collapse into single outcomes during observation. Others propose that all possible outcomes continue simultaneously across branching realities. Even among experts, there is still disagreement regarding what quantum mechanics ultimately says about existence itself. And throughout history, many philosophical traditions reach their own conclusions about the uncertain nature of reality long before modern physics emerged. In ancient Greece, Plato described a famous thought experiment now called the allegory of the cave. In the story, prisoners spend their entire lives chained inside a cave, seeing only shadows projected onto a wall, because the shadows are all they have ever known. The prisoners mistake them for reality itself, but eventually, one prisoner escapes the cave and discovers the larger world outside. The sunlight is overwhelming at first, almost painful to experience. But slowly, the prisoner realizes that what once seemed unquestionably real was only a partial reflection of something much larger. Across cultures and centuries, similar questions continued appearing again and again. How much of reality is perception? How much is interpretation? And how much remains hidden beyond ordinary awareness because human beings exist inside consciousness itself, and consciousness may be the strangest phenomenon of all. Right now, somehow, electrical activity inside the brain is producing subjective experience, thoughts, emotions, awareness, the feeling of being you. And despite centuries of philosophy, religion, and neuroscience, humanity still does not fully understand how consciousness emerges at all. Scientists can identify brain regions associated with perception, emotion, language, and memory, but the deeper mystery remains. Why does any of this produce inner experience in the first place? Why should matter arranged in a certain way suddenly become self-aware? This question is sometimes called the hard problem of consciousness, because even if scientists mapped every neuron perfectly, the existence of subjective experience would still remain deeply mysterious. And perhaps that is part of what makes the question of reality so enduring. The closer human beings examine existence, the less simple it appears to become. What once looked solid becomes uncertain. What once looked obvious becomes mysterious. And what once seemed permanent begins to shift under closer observation. But for now, there is no need to solve the mystery completely. There is only the quiet exploration of it, the slow realization that reality may be far stranger, far deeper, and far more mysterious than it first appears, and somewhere beyond the movement of thoughts, beyond language, beyond memory and explanation, the universe continues quietly around us. Silent stars moving across dark skies. Light traveling unimaginable distances through space. And conscious minds briefly awakening within it all. And so, if human beings experience reality through perception, then the next question becomes unavoidable. How much of reality is actually being constructed inside the mind? Because the brain does not simply record the world like a camera. It predicts, interprets, fills gaps, filters information, and continuously builds a simplified model of reality based on limited sensory input. At every moment, human beings are surrounded by enormous amounts of information. Light reflects off every surface. Air carries vibrations constantly. The body sends signals about temperature, balance, pressure, pain, movement, and internal organ activity, all at the same time. But conscious awareness only receives a very small portion of this information directly. Most processing happens automatically beneath awareness itself. The brain constantly decides what matters enough to notice and what can safely be ignored. For example, most people stop noticing the feeling of clothing against their skin after only a few moments. The sensation still exists. The nervous system still detects it. But attention gradually filters it out. The same thing happens with background sounds, familiar smells, or repeated visual patterns. Human perception evolved primarily for survival, not for perfectly objective understanding. The brain prioritizes efficiency over total accuracy. This means that what humans experience as reality is often shaped heavily by expectation and prediction. Modern neuroscience increasingly suggests that perception itself may function partly as a prediction system, rather than waiting passively for information. The brain actively generates expectations about the world and then updates those expectations based on incoming sensory data. In a sense, the mind is continuously guessing reality and correcting itself moment by moment. Optical illusions reveal this surprisingly well. Certain images can appear to move even when completely still. Straight lines can appear curved. Colors can seem to change depending on surrounding context. The eyes may receive identical visual information, but the brain interprets it differently, depending on surrounding patterns and assumptions. This becomes even stranger when examining how incomplete human perception actually is. There is a small blind spot in each eye where the optic nerve passes through the retina. In that area, there are no light detecting cells at all. And yet, people normally never notice this blind spot because the brain automatically fills in missing information using surrounding visual patterns. Reality as humans experience it is therefore partially reconstructed continuously without conscious awareness. The same is true for motion. Movies and videos appear smooth and continuous, but they are actually sequences of still images shown rapidly in succession. The brain merges them into fluid movement. Even the experience of a stable world may depend partly on constant reconstruction occurring inside the nervous system. Dreams provide another strange example. While dreaming, the brain can generate entire environments, people, conversations, stories, and emotional experiences that feel completely real in the moment. Only upon waking does the mind often recognize the instability or impossibility of the dream itself. This raises an unsettling possibility. If the mind can generate convincing realities internally during dreams, how certain can human beings be about ordinary waking perception? Philosophers have explored versions of this question for centuries. The French philosopher René Descartes famously wondered whether it was possible to prove with certainty that reality was not some form of illusion or deception, because every sensory experience ultimately arrives through consciousness itself. There is always some degree of uncertainty regarding the external world beyond perception. Descartes eventually concluded that the one thing impossible to doubt was the existence of awareness itself. The very act of questioning reality proved that a conscious observer existed to ask the question. This led to his famous statement, "I think, therefore I am," and yet even the sense of self becomes surprisingly unstable under close examination. Many people experience the self as a solid, continuous identity moving through time. But neuroscience suggests the brain continuously updates and reconstructs identity as circumstances change. Cells in the body are replaced gradually over time. Memories shift, beliefs evolve, personality changes with age and experience. The person someone was at age 5 may think very differently than the person they become decades later. And yet, most people still experience a sense of continuity, connecting all these changing versions together. Where exactly does this continuity come from No single location in the brain appears to contain a permanent self. Instead, identity may emerge from ongoing patterns of memory, attention, emotion, and narrative construction. In other words, the self may function less like a fixed object and more like an ongoing process. Some philosophical and spiritual traditions arrived at similar conclusions long before modern neuroscience. Certain Buddhist traditions, for example, suggest that the permanent independent self humans normally perceive may ultimately be an illusion created by attachment and mental habit. According to these ideas, human experience consists more of constantly changing processes than fixed permanent identities. Thoughts change, emotions change, the body changes, perception changes, and awareness itself flows continuously from moment to moment. This perspective does not necessarily deny experience, but it questions whether the stable self humans feel is truly permanent in the way it appears. Modern psychology also reveals how strongly emotion influences perception. Fear can make harmless situations feel threatening. Sadness can alter memory recall. Anxiety can distort interpretation of uncertainty. Two people can experience the same event and remember it very differently based on emotional state and personal expectation. Even social reality depends partly on shared collective belief. Money, laws, governments, social norms, and national borders all function because large groups of people collectively agree to treat them as real and meaningful. These systems have powerful effects in daily life, but they are also human constructions maintained through shared belief and cooperation. This demonstrates that reality exists on multiple levels simultaneously. There is physical reality, biological reality, psychological reality, social reality, and symbolic reality. And human beings move through all of them constantly. The deeper one examines perception, the more complicated reality appears to become. Not necessarily unreal, but layered, filtered, interpreted, and deeply dependent on consciousness itself. And perhaps this is part of what makes existence feel so mysterious. Human beings are simultaneously observers inside the universe, while also being products of the universe, attempting to understand itself. Matter became alive. Life became conscious. And consciousness began questioning the nature of reality itself. A strange chain of events unfolding across billions of years of cosmic history. And still, despite science, technology, and philosophy, many of the deepest questions remain unresolved. What is consciousness? What is perception? What is the self? And how much of reality exists beyond the limits of human awareness? Questions that continue quietly expanding the longer they are examined, like stars slowly emerging one by one in a darkening sky. And so, as human beings began questioning perception itself, another possibility slowly emerged. What if ordinary waking reality is not the full picture? This question appears repeatedly across philosophy, religion, science fiction, and modern physics discussions alike, because throughout history, people have noticed something strange about consciousness. The mind is capable of generating convincing realities internally. Dreams are one example. During a dream, events often feel immediate and believable while they are happening. The brain constructs environments, people, movement, sound, emotion, and narrative in real time. A person may run through cities that do not exist, speak with people long gone, or experience impossible events that still feel emotionally real in the moment. Only after waking does the instability of the dream become obvious. But while dreaming, the mind often accepts the experience completely. This has led philosophers for centuries to ask a difficult question: how can anyone know with absolute certainty that waking reality is fundamentally different? The ancient Chinese philosopher Zhuangzhou once described a famous paradox, now known as the butterfly dream. In the story, he dreamed he was a butterfly, moving freely and naturally through the world. When he awoke, he wondered whether he was truly a man who had dreamed of being a butterfly, or a butterfly now dreaming of being a man. The story was not necessarily meant as literal confusion, but as a reflection on the uncertainty of perception and identity. Because consciousness itself can produce experiences that feel entirely real from within them. Modern neuroscience has shown that dreams activate many of the same brain systems involved in waking perception. Visual regions become active. Emotional systems respond intensely. Narratives unfold. Fear, joy, stress, and attachment can all appear vividly within dreams. And yet, the external environment may remain completely quiet while this internal world unfolds. This suggests something profound about the human mind. Experience itself is generated internally. The outside world may influence consciousness, but conscious experience ultimately exists within the brain's interpretation of reality. This idea eventually expanded into more modern philosophical questions about simulation and artificial reality. As computer technology advanced, some philosophers began asking whether consciousness could theoretically exist inside simulated environments, indistinguishable from physical reality. If a simulated world became detailed enough and conscious beings inside it had no outside reference point, would they recognize it as artificial, or would it simply become their reality? This question became widely discussed through what is now called simulation theory. The idea proposes that sufficiently advanced civilizations might eventually possess the technological ability to simulate conscious worlds in enormous detail. And if such simulations became possible, there could theoretically be many simulated realities compared to one original reality. Under this logic, some philosophers argue that statistically, it might even become more likely for conscious beings to exist inside simulations than outside them. This idea remains highly speculative, and there is currently no scientific evidence proving reality is a simulation. But the theory became popular because it touches a deeper philosophical uncertainty that has existed for thousands of years. The possibility that human beings may not fully understand the structure of reality they inhabit. Interestingly, modern physics sometimes produces conclusions that also challenge ordinary intuition. At large scales, the universe appears stable and predictable, but at quantum scales, certainty becomes less clear. Particles behave probabilistically. Observation affects measurement, and the deeper scientists investigate matter itself, the less solid reality often appears to become. Atoms, which once seemed like tiny solid building blocks, are themselves mostly empty space structured by energetic relationships between particles and fields. The human body, the earth, mountains, oceans, and stars are all ultimately composed of these same underlying structures. What appears solid at human scale becomes far stranger at microscopic scale, and modern physics also suggests that ordinary human perception captures only a tiny fraction of the universe itself. Human eyes detect only a narrow band of the electromagnetic spectrum. Outside visible light exist radio waves, infrared, ultraviolet, X-rays, gamma rays, and many other forms of energy humans cannot perceive directly. Many animals perceive reality differently than humans do. Some birds can sense Earth's magnetic field. Certain snakes detect heat. Bees can see ultraviolet patterns invisible to human eyes. Bats navigate through echolocation. Each species experiences only part of reality according to the structure of its sensory systems. This raises another unsettling question. How much of reality exists beyond human perception entirely? The universe humans experience may represent only a narrow slice of a far larger structure. Even space itself remains mysterious. Modern cosmology suggests that ordinary, visible matter may account for only a small percentage of the universe's total composition. Most of the cosmos appears to consist of dark matter and dark energy, phenomena that scientists infer through gravitational effects, but still do not fully understand. In other words, most of the universe may consist of things humanity cannot directly perceive or fully explain. And despite extraordinary scientific advancement, human beings still do not know why the universe exists at all. Why is there something rather than nothing? Why do physical laws exist? Why does mathematics describe reality so effectively? Why did consciousness emerge? The deeper the investigation becomes, the larger the mystery often appears. And perhaps this is why questions about reality continue returning across civilizations and centuries, because human beings exist in a strange position, aware enough to recognize mystery, but limited enough to never fully escape uncertainty. Consciousness peers outward into the universe, while also being trapped inside its own perception at the same time. And somewhere within that uncertainty, between waking and dreaming, between matter and awareness, between certainty and mystery, the question quietly remains: what is reality? And so, as human beings questioned perception, dreams, and consciousness, another realization slowly emerged through science itself. Reality may be far stranger than ordinary intuition allows, because for most of human history, space and time appeared simple. Space seemed fixed and unmoving. Time seemed constant. The universe appeared stable and predictable at human scale. But during the early 20th century, physics began uncovering something deeply unexpected. Time and space were not separate background structures after all. They were connected. Albert Einstein's theory of relativity transformed how scientists understood reality itself. According to relativity, space and time form a unified structure now called space-time. Massive objects such as planets, stars, and black holes actually bend space-time around them. What humans experience as gravity is partly the effect of this curvature. The Earth is not simply pulling objects downward through invisible force alone. Instead, matter changes the geometry of space-time itself, and objects move through that curved geometry. This idea sounds abstract at first, but its effects are measurable and real. Even time itself behaves differently depending on gravity and motion. Clocks closer to massive objects tick slightly more slowly than clocks farther away. A person near an extremely strong gravitational field would experience time differently relative to someone farther away. This phenomenon is called gravitational time dilation. It has been confirmed experimentally many times. Even GPS satellites orbiting Earth must constantly correct for relativistic differences in time caused by both speed and weaker gravity farther from Earth's surface. Without these corrections, navigation systems would become inaccurate surprisingly quickly. This means that time is not perfectly universal. Different observers moving under different conditions can experience time differently. Something that once seemed absolutely fixed turns out to be flexible under certain conditions, and the deeper physics explored reality, the stranger the universe appeared to become. Black holes became one of the most extreme examples. A black hole forms when enormous amounts of matter collapse into a region so dense that gravity becomes overwhelming. Beyond a boundary called the event horizon, not even light can escape, because light itself cannot escape. Black holes appear completely dark against space. And near these objects, the distortion of space-time becomes extraordinary. To an outside observer, time near a black hole appears to slow dramatically. A person approaching the event horizon would appear to move more and more slowly from the perspective of someone far away. Meanwhile, from the traveler's own perspective, time might continue feeling relatively normal. Reality itself depends partly on the observer's frame of reference. This idea appears repeatedly throughout modern physics. There is no single universal perspective equally shared across all conditions. Observation depends on location, motion, gravity, and relationship within space-time itself. And while relativity describes the universe extremely well at large scales, another branch of physics emerged that described reality at the smallest scales imaginable: quantum mechanics. Together, relativity and quantum mechanics became the two most successful scientific theories ever developed. And yet, They describe reality in radically different ways. Relativity describes smooth space-time and predictable gravitational structure. Quantum mechanics describes probabilities, uncertainty, and strange microscopic behavior that often defies ordinary intuition. At quantum scales, particles can behave like waves. Objects can exist in uncertain states until measured, and quantum entanglement allows particles separated across large distances to remain mathematically connected in surprising ways. Einstein himself found some of these implications deeply unsettling. He famously referred to quantum entanglement as spooky action at a distance because it seemed to challenge ordinary assumptions about separation and locality. And despite decades of scientific advancement, physicists still do not fully understand how relativity and quantum mechanics fit together into one unified description of reality. Some researchers search for a deeper theory capable of connecting both systems. Ideas such as string theory, loop quantum gravity, and quantum gravity models attempt to bridge this gap, though no complete solution has yet been confirmed experimentally. This means that even modern science still contains major unanswered questions about the fundamental structure of existence. And then there is the universe itself. For thousands of years, many people believed the cosmos had existed eternally in roughly its present form. But modern cosmology suggests the observable universe had a beginning approximately 13.8 billion years ago. The Big Bang theory describes a period when the universe was once compressed into an extremely hot, dense state before expanding outward over immense spans of time. As the universe expanded, matter cooled, atoms formed, stars ignited, galaxies emerged, and eventually planets and life appeared. Everything humans have ever known, every ocean, mountain, tree, animal, city, and human life formed within this expanding cosmic history. And yet, the Big Bang theory does not fully explain what came before the early expansion, or why the universe exists at all. In fact, ordinary ideas about before may not even apply in simple ways if time itself emerged with the universe. This creates one of the strangest philosophical implications in cosmology. If time began as part of the universe, then asking what happened before the universe may be similar to asking what lies north of the North Pole. The question itself may depend on assumptions that stop functioning at certain extremes. And still, human curiosity continues pushing outward. Modern telescopes now observe galaxies billions of light years away because light takes time to travel. Looking into deep space also means looking backward in time. Some of the stars visible in the night sky no longer exist in the present. Their light simply continues traveling across space long after the stars themselves have changed or disappeared. Human beings therefore live inside a universe where the past remains visible constantly. The night sky itself becomes a record of time unfolding across unimaginable distances. And perhaps this is part of what makes reality feel so mysterious. The deeper human beings explore existence, the more reality begins resisting ordinary common sense. Space bends, time changes, matter behaves probabilistically. Observation affects measurement, and the universe itself emerges from origins still not fully understood. Yet, despite all this complexity, human consciousness somehow experiences existence moment by moment, breath by breath, beneath stars, moving silently overhead. And somewhere within that enormous cosmic structure, awareness briefly awakens, looks outward into the universe, and wonders what any of it truly is. And so, as science continued exploring matter, space, time, and the structure of the universe, another mystery remained unresolved at the center of everything: consciousness itself. Because regardless of how much physics explains about particles or gravity, human beings still experience something deeply unusual from the inside: awareness, the direct experience of seeing color, hearing sound, feeling emotion, remembering the past, imagining the future, and experiencing the sense of being a conscious self moving through reality. And despite enormous advances in neuroscience, scientists still do not fully understand how subjective experience emerges from physical matter. The brain is made from cells, electrical activity, chemical signaling, and biological structures shaped through evolution. Neurons communicate through electrochemical impulses. Networks process information continuously. Different brain regions specialize in language, vision, movement, emotion, and memory. Damage to certain areas of the brain can alter personality, decision-making, speech, or emotional regulation. This strongly suggests that conscious experience is deeply connected to physical brain activity. And yet, a major philosophical problem remains. Why should physical processing produce subjective experience at all? Why should electrical activity inside neurons generate the feeling of redness, the taste of food, the experience of sadness, or the awareness of existence itself? This question became known in philosophy of mind as the hard problem of consciousness. The term was introduced by philosopher David Chalmers during the 1990s. Scientists can increasingly explain mechanisms associated with consciousness, how visual processing works, how memories form, how attention shifts, or how information moves through neural systems. These are sometimes called the easy problems of consciousness, not because they are actually easy, but because they involve observable mechanisms that can theoretically be studied scientifically. But subjective experience itself remains different. No brain scan can directly reveal what another person's inner experience feels like. A scientist might observe neural activity associated with pain, but the actual sensation of pain still exists privately within conscious experience itself. Philosophers sometimes refer to these private, subjective qualities as qualia: the redness of red, the taste of coffee, the feeling of cold water, the emotional weight of grief. These experiences are directly known internally, but difficult to explain purely through objective measurement. This creates a strange gap between physical description and lived experience. A complete scientific description of light wavelengths does not automatically explain why humans experience color consciously. A perfect map of sound frequencies does not explain the subjective feeling of hearing music. Some philosophers and neuroscientists argue that consciousness may eventually be explained entirely through physical processes once neuroscience becomes advanced enough. Others believe consciousness may represent something fundamentally different, or at least something not yet fully understood within current scientific frameworks. Several major theories attempt to explain consciousness today. One influential theory is called integrated information theory, sometimes shortened to IIT. This theory proposes that consciousness emerges from systems capable of integrating large amounts of information into unified experience. According to this view, consciousness depends not only on processing information, but on how interconnected and unified that processing becomes. Another major framework is global workspace theory. This model compares consciousness to a kind of mental workspace where information becomes globally available across different brain systems. Many unconscious processes occur constantly beneath awareness, but certain information enters conscious awareness when it becomes widely accessible throughout the brain. There are also more radical theories. Some philosophers propose forms of panpsychism, the idea that consciousness or proto-conscious experience may exist at some level throughout reality itself. This does not necessarily mean rocks think like humans, but rather that consciousness may be a more fundamental feature of existence than previously assumed. Other thinkers reject this idea entirely and maintain that consciousness emerges only from highly complex biological systems. The debate remains unresolved, and the mystery deepens further when examining the self. Human beings typically experience themselves as unified individuals with continuous identity over time. But neuroscience increasingly suggests that the brain contains many semi-independent systems operating simultaneously. Different neural networks compete, cooperate, and process information in parallel. In some neurological conditions, this unity can partially break down. Split brain patients provide one famous example. In certain severe epilepsy cases, surgeons historically severed the corpus callosum connecting the brain's hemispheres in order to reduce seizure spread. Afterward, researchers discovered surprising effects under some conditions. The left and right hemispheres appeared capable of processing information somewhat independently. One hand might perform actions the conscious verbal mind struggled to explain fully. These experiments suggested that the feeling of being a single unified self may partly emerge from coordination between multiple systems rather than from one central observer inside the brain. There is also no obvious location in the brain where a permanent self exists. No single neuron contains identity. No specific region appears to house a stable observer separate from the rest of the system. Instead, the self may emerge gradually from memory, attention, emotion, body awareness, and narrative continuity. In many ways, the brain continuously tells a story about who a person is. And this story changes over time. Memories shift, beliefs evolve, personality adapts to experience. The body ages, yet most people still feel like the same person across decades of life. This continuity may partly emerge because the brain constantly updates identity while preserving enough coherence to maintain stability. But even memory itself is imperfect. Research shows that memories are reconstructive rather than perfectly stored recordings. Each time a memory is recalled, it becomes vulnerable to modification before being stored again. Emotions influence recollection strongly. Suggestions can alter details, and false memories can sometimes become convincing enough that people feel certain about events that never occurred exactly as remembered. This means that human identity is partly built from systems that continuously reconstruct the past. And yet, despite these uncertainties, conscious experience remains immediate and undeniable from within. A person may doubt external reality, memory, or perception, but awareness itself continues unfolding moment by moment. This led some philosophers to conclude that consciousness may be the most fundamental certainty humans possess. Everything else, the external world, physical matter, space, time, even identity itself, is experienced through consciousness first. Without awareness, there is no experience of reality at all. And perhaps this is why the mystery remains so difficult to solve. Human beings are trying to use consciousness to fully understand consciousness itself. The observer and the thing being observed are intertwined. A conscious universe has produced beings capable of questioning the nature of awareness. But those beings remain trapped within awareness while attempting to explain it. And the deeper the investigation becomes, the more the boundary between physics, philosophy, psychology, and existential mystery begins to blur. And so, as human beings continued investigating consciousness, another strange pattern began appearing throughout science itself. The universe seems deeply mathematical, from planetary motion to atomic structure to gravity to electromagnetism. Mathematics repeatedly describes reality with extraordinary precision. Equations developed through abstract thought often end up predicting real physical phenomena long before those phenomena are directly observed. This has happened many times throughout scientific history. In the 19th century, James Clerk Maxwell developed equations describing electromagnetism. Those equations predicted the existence of electromagnetic waves before technologies like radio were ever invented. Later, Einstein's equations predicted gravitational lensing and black holes before direct observational evidence existed. The mathematics came first. Reality appeared to follow afterward. This raises a profound question. Why should mathematics describe the universe so effectively at all? Mathematics is ultimately a symbolic system created within human minds. And yet, somehow, Abstract mathematical structures repeatedly align with the behavior of physical reality itself. Physicist Eugene Wigner famously referred to this as the unreasonable effectiveness of mathematics, because the relationship between mathematical abstraction and physical existence remains deeply mysterious. Some thinkers argue mathematics is invented by humans. Others argue mathematics is discovered, that mathematical relationships exist independently of human thought and are gradually uncovered over time. If that is true, then the universe may possess underlying structures that exist whether humans observe them or not. Patterns, ratios, symmetries, and relationships woven into reality itself. Symmetry, in particular, appears repeatedly throughout physics. Many physical laws remain unchanged under certain transformations. For example, the laws of physics behave consistently, regardless of where an experiment is performed in space. This consistency allows stable scientific prediction and understanding. At microscopic scales, particles and forces often behave according to elegant mathematical symmetries that physicists continue attempting to unify into larger frameworks. Some scientists believe reality may ultimately emerge from informational or mathematical structure at the deepest level. Others reject this idea as overly abstract speculation. But regardless of interpretation, modern physics increasingly suggests that ordinary human intuition evolved for survival, not for understanding the deepest architecture of the cosmos. Human beings evolved at middle scales, moving through forests, grasslands, weather systems, and social groups. The brain became extremely effective at understanding survival-sized reality, throwing objects, reading faces, tracking movement, recognizing danger, predicting immediate outcomes. But reality at cosmic scale and quantum scale behaves very differently from ordinary human experience. At human scale, objects appear solid. Time feels continuous. Causes produce predictable effects. At relativistic scales, time bends. At quantum scales, certainty breaks down into probabilities. And at cosmic scales, the observable universe extends across distances so enormous that human intuition struggles to process them meaningfully. Light from distant galaxies may take billions of years to reach Earth. Some stars visible tonight no longer exist in the present moment. The observable universe itself contains hundreds of billions of galaxies, each containing billions or even trillions of stars. And yet, the observable universe may only represent part of a much larger total structure. Some cosmological models suggest space could extend infinitely beyond what humans can observe. Others propose multiverse theories, where many universes with different physical conditions may exist simultaneously. These ideas remain speculative, but they emerge naturally from certain interpretations of cosmology and quantum theory. Again and again, the deeper reality is examined, the less centered human beings appear within it. For much of history, humans assumed Earth stood at the center of existence. Then astronomy revealed Earth orbiting the Sun. Later, the Sun became one star among billions in the Milky Way. Then the Milky Way became one galaxy among billions more, and modern cosmology suggests even the visible universe may not be the entirety of existence itself. This progressive expansion of scale has transformed humanity's understanding of reality repeatedly. At the same time, human beings remain physically tiny compared to cosmic structures, yet strangely capable of understanding aspects of them mathematically. Small biological organisms evolving on one planet somehow developed the ability to detect black holes, measure the age of stars, split atoms, and calculate the expansion rate of the universe. This creates another strange paradox. Human beings are simultaneously insignificant in scale, yet unusually capable of abstract understanding. The universe became conscious enough in at least one location to study itself scientifically. And despite all scientific progress, there are still major limits to human understanding. The observable universe itself is limited by the speed of light. There are regions so distant that light from them has not had time to reach Earth since the beginning of cosmic expansion. There may therefore be enormous portions of reality forever inaccessible to direct observation. Quantum uncertainty also imposes limits. Werner Heisenberg's uncertainty principle demonstrated that certain properties, such as position and momentum, cannot both be known with perfect precision simultaneously. This is not simply a technological limitation. It appears built into the structure of quantum reality itself. There are also theoretical limits to information. Black hole thermodynamics suggests deep relationships between gravity, entropy, and information storage. Some physicists now suspect information may play a more fundamental role in reality than previously assumed. Theoretical physicist John Wheeler once summarized this possibility with the phrase, "it from bit." The idea suggests physical reality may ultimately emerge from informational structure at the deepest level. Whether this is true remains uncertain. But modern physics increasingly blurs traditional boundaries between matter, energy, information, observation, and mathematics. And still, despite all of this complexity, ordinary human experience continues quietly. People wake each morning, drink coffee, watch sunsets, feel loneliness, fall in love, remember childhood, fear death, look upward at stars. The universe may be incomprehensibly large and mathematically strange, yet conscious life continues experiencing existence through immediate moments of perception and emotion. Perhaps this contrast is part of what makes reality feel so mysterious. Human beings exist between two extremes at once: the vast, impersonal scale of the cosmos and the deeply personal immediacy of conscious experience. A species made from atoms, born inside ancient stars, attempting to understand the structure of existence while temporarily alive within it. And somewhere between mathematics, matter, memory, and awareness, the mystery of reality continues unfolding quietly. And so, as human beings continued exploring consciousness, physics, mathematics, and the structure of reality, another difficult question slowly emerged from the center of human experience itself. Do human beings truly possess free will, or are thoughts, choices, and actions ultimately determined by processes already unfolding beneath awareness? At first, most people experience decision making as straightforward. A person chooses what to say, what to eat, where to go, who to love, what career to pursue. The experience of making choices feels immediate and real. But philosophers and scientists have debated for centuries whether this feeling reflects genuine freedom, or whether human decisions are ultimately produced by prior causes extending backward indefinitely through biology, environment, physics, and time itself. One major philosophical position is called determinism. Determinism proposes that every event emerges from prior conditions according to the laws of nature. Under strict determinism, every thought, emotion, decision, and action would ultimately result from earlier causes. Your genetics, your childhood experiences, your environment, your memories, your neurochemistry, the current state of your brain, all interacting continuously according to physical processes. In this framework, human choice may feel free internally, while still being fully caused by prior events. This idea became especially influential after the scientific revolution, when physicists discovered that many aspects of nature behaved according to predictable mathematical laws. If the universe functions mechanically, then perhaps human beings, as physical systems inside that universe, also follow causal chains, whether they recognize them or not. French mathematician Pierre-Simon Laplace once imagined a hypothetical intelligence, now called Laplace's demon. If such an intelligence knew the exact position and motion of every particle in the universe at one moment, it could theoretically predict the entire future perfectly. Every future event, every human action, every thought. The universe would unfold like an enormous chain of cause and effect. This vision of reality became deeply influential for centuries, but modern science complicated the picture significantly. Quantum mechanics introduced genuine uncertainty into physics at microscopic scales. Certain quantum events appear probabilistic rather than strictly deterministic. Particles do not always possess perfectly defined states before measurement. Instead, quantum systems are described through probabilities. Some people interpreted this uncertainty as evidence supporting free will, but randomness alone does not necessarily create meaningful freedom. A random process is not the same thing as conscious control. Even today, scientists and philosophers continue debating how quantum uncertainty relates, if at all, to human decision-making. Neuroscience added another layer to the debate. Experiments studying brain activity revealed something surprising. In some studies, measurable neural activity associated with decisions appears slightly before subjects become consciously aware of deciding. One famous series of experiments was conducted by neuroscientist Benjamin Libet during the 1980s. Participants were instructed to make simple, spontaneous movements, such as flexing a finger, while noting the moment they became consciously aware of the intention to act. Researchers detected a buildup of neural activity called the readiness potential before subjects reported conscious awareness of their decision. This raised difficult questions. If unconscious brain processes begin preparing actions before conscious awareness notices the decision, then what role does conscious choice actually play? Some researchers interpreted these findings as evidence that unconscious neural systems initiate decisions before the conscious mind becomes aware of them. Others argued the experiments oversimplified decision-making and could not fully explain complex human choices involving reasoning, reflection, morality, or long-term planning. The debate remains unresolved, and ordinary human experience itself remains difficult to explain completely through simple models. People often feel internally divided during decision-making. Part of the mind may want one thing, while another part resists. Emotions conflict with logic. Impulses conflict with long-term goals. Habits compete with conscious intention. This suggests the brain may contain multiple interacting systems rather than one unified controlling entity. Modern psychology often describes two broad categories of cognition: fast automatic thinking and slower reflective thinking. Automatic processes handle many behaviors unconsciously: walking, reading familiar words, recognizing faces, driving familiar routes. Emotional reactions. These systems operate rapidly and efficiently beneath conscious awareness. Slower, reflective thinking allows deliberate reasoning, planning, and self-control, but requires effort and attention. Human behavior may therefore emerge from interaction between many layers of neural processing, rather than from a single central commander. There are also strong biological influences on behavior. Hormones affect mood and motivation. Sleep deprivation impairs judgment. Stress alters decision-making. Trauma can reshape emotional responses for years. Genetics influence personality tendencies, risk tolerance, attention, and emotional regulation. Environmental conditions also shape development profoundly. Childhood stability, nutrition, education, social connection, violence, poverty, and opportunity all influence the developing brain over time. This creates another difficult question. To what extent can people truly separate themselves from the conditions that shape them? At the same time, human beings clearly possess some capacity for reflection and self-modification. People can examine habits, resist impulses, change belief systems, develop discipline, learn from mistakes, and deliberately alter behavior over long periods of time. Meditation practices, therapy, education, and conscious training can reshape patterns of thought and emotional response measurably. Neuroscience refers to this adaptability as neuroplasticity. The brain remains capable of changing its structure and connections throughout life in response to experience and repeated behavior. This suggests that while humans are influenced by biology and environment, they are not completely rigid systems either. Some philosophers therefore adopt positions called compatibilism. Compatibilists argue that meaningful forms of free will can still exist even within a causal universe. According to this view, freedom may not require absolute independence from causation. Instead, freedom may involve the ability to act according to internal motivations, reasoning, values, and reflection without external coercion. In this framework, human beings remain influenced by prior causes, while still capable of meaningful agency within those constraints. Other philosophers reject free will almost entirely, arguing that the sense of authorship may itself be partly constructed by the brain after decisions emerge unconsciously. And still others believe consciousness may involve aspects not yet fully understood scientifically. The uncertainty remains, but perhaps the deeper mystery is not simply whether free will exists, but how strange human awareness becomes when examined closely. A conscious organism built from physical matter somehow develops identity, memory, desire, fear, hope, morality, and the feeling of choosing its own future, whether fully free or partially constrained. Human experience still unfolds through decisions, relationships, regret, curiosity, and imagination. People still struggle with responsibility, still wrestle with meaning, still attempt to become better versions of themselves over time. And somewhere inside this enormous universe, billions of conscious minds continue making choices, or at least experiencing the feeling of making choices, moment by moment, while reality itself remains only partially understood. And perhaps that uncertainty is unavoidable, because human beings are not outside reality, examining it from a distance. They are inside it. Small, temporary forms of conscious matter, trying to understand the system that produced them, while still fully embedded within it. And so, after centuries of philosophy, science, religion, mathematics, and observation, the question still remains quietly unresolved. What is reality? Human beings have traveled from ancient myths to particle accelerators, from cave paintings to space telescopes. from oral storytelling to quantum theory. And with each new discovery, reality often becomes less simple rather than more. The universe appears mathematically structured, yet filled with uncertainty. Matter behaves predictably at one scale and strangely at another. Time feels steady in everyday life, yet bends under gravity and motion. Consciousness emerges somehow from physical systems, yet subjective experience remains deeply mysterious. Human beings perceive the world continuously, while also knowing perception itself is filtered, reconstructed, and incomplete. Even the self, which feels so immediate and personal, may be less stable and permanent than it first appears. And still, despite all uncertainty, experience continues. People continue waking each morning into a world that feels real. They form memories, build relationships, feel grief, experience joy, watch seasons change, look upward at the night sky. Reality may be uncertain in its deepest structure, but human life unfolds within it all the same. Perhaps this is why the mystery has never disappeared. Because the question of reality is ultimately also a question about consciousness, existence, and the strange condition of being alive at all. A universe made of matter somehow became capable of awareness. Stars formed heavy elements. Those elements became planets. On at least one world, chemistry slowly became biology. Biology became increasingly complex. Nervous systems emerged. Perception developed. Memory developed. Language developed. And eventually, conscious beings began asking questions about the nature of existence itself. The universe became capable of observing itself. And yet, human understanding remains limited. The observable universe may be only a fraction of total reality. Consciousness may involve principles not yet fully understood. Physics still contains unresolved contradictions between quantum mechanics and gravity. Dark matter and dark energy remain largely mysterious. The origin of existence itself remains uncertain, and perhaps there are aspects of reality the human brain is simply not equipped to fully comprehend. After all, human perception evolved for survival on Earth, not necessarily for understanding the deepest architecture of the cosmos. Other animals perceive reality differently. A bee experiences ultraviolet patterns invisible to humans. A bat navigates through echolocation. Certain birds sense magnetic fields. Each species experiences only part of reality according to the structure of its senses and nervous system. Human beings may also experience only a narrow slice of what truly exists. There may be layers of reality permanently outside ordinary awareness. And yet, within that narrow slice, human beings created art, music, science, mathematics, philosophy, and stories attempting to describe existence across cultures and centuries. People repeatedly searched for patterns connecting themselves to something larger. Some looked toward religion, others toward science, others toward meditation, reason, or direct experience. But beneath all these approaches remains the same underlying mystery. Why is there something rather than nothing? Why does the universe exist? Why does consciousness exist within it? And why should matter arranged in certain ways suddenly become aware of itself? No final answer has yet emerged. Perhaps none ever will. But there is something strangely beautiful about that uncertainty. Because reality is not merely a solved equation waiting at the end of history, it is something continuously unfolding, expanding, changing, revealing deeper layers the more closely it is examined. Even now, far beyond Earth, stars continue forming inside cold molecular clouds. Galaxies continue drifting through expanding space. Light from ancient objects continues traveling silently across the universe, moving for billions of years before finally reaching human eyes. And here, on one small planet orbiting one ordinary star, consciousness briefly awakens for a short period of time, long enough to wonder about the nature of existence itself, long enough to ask questions no other known form of matter appears capable of asking. What is reality? What is consciousness? What is time? What is the self? Questions suspended quietly inside a universe that may never fully explain itself. And perhaps that is enough for now. Not complete certainty, but quiet curiosity. The awareness that reality is deeper than it first appears, and stranger than human intuition once imagined. Outside, the Earth continues turning slowly through space. The atmosphere moves softly across oceans and forests. Clouds drift over sleeping cities. Moonlight reflects from rivers, from rooftops, from empty roads at night. Far above them, stars continue burning in enormous silence. some already gone, their light still traveling patiently through darkness, and somewhere beneath those distant stars, thoughts begin slowing. Questions soften at the edges. The need for answers grows quieter until awareness itself starts drifting gently between certainty and mystery, between thought and stillness, between the feeling of self and the endless quiet surrounding it, as the universe continues unfolding slowly in every direction, silent, vast, and impossibly deep.